Hey guys, what's up? See, I'm back here and back with another topic, and this is also going to be another topic from biomolecules. What I was doing in the previous lecture was it was about introduction of the fructose, where I described some of the very important facts about fructose, and it's also the open structure. But there are so many properties of fructose that is more of like the glucose. So those properties I'll be discussing, and the key points in today's lecture is going to be its cyclic structure development, right? Hemiacetal cyclic development of fructose, and its alpha and beta form of fructose, right? So for that we need to draw the open structure first, and then we can do the alpha and beta form of the fructose. So what I'm going to do, I'm going to draw a structure right here. Just pay attention, this is going to be really again easy and very useful to you as well. The first carbon in the fructose is in the form of CH2OH, and this is A chiral. The second one is in the form of a keto group, and the third one is having hydrogen on the right hand side and OH on the left hand side. This is something you cannot ignore, like you can place it anywhere, OH and H, because this is structurally been already identified by chemical reaction. It was done in the glucose, but similar reactions have been carried out to find out the position of OH and H. So the third OH is on the left hand side, the fourth and fifth they are on the right hand side. So this is your fifth H and OH, and then you have your sixth one, that is also 1 2 3 4 5. So H is again here, and like this, and the last one, like the glucose, it is also in the form of CH2OH. So what I want to tell you here is that the first carbon and this last carbon, and also this carbonyl carbon, these are achiral. So let me write this here, first, right, second and sixth carbon are achiral, right? I hope you do know that achiral means that all the four substituents are not different, right? So this may be sp3 hybridized, this is also sp3 hybridized, but two of the substituents are hydrogen here, that's why it's achiral, and this one is not even in consideration because it has a hybridization of sp2, right? So what that means, that these three carbons are chiral. So I'm going to write it here again, that third, fourth and fifth. So 3, 4 and 5 are chiral, right? So 3, 4 and 5 are chiral, but other 3 are achiral. Now what this is called, this is your fructose here, right? This is your fructose. So what I'm going to do, I'm actually going to make you go about the hemiacetal cyclic structure of the fructose. For that I have to isolate this hydrogen, something like this, and you do know that there are two lone pair out here on the oxygen. So what happened, this lone pair from the fifth carbon, this is your fifth carbon here, and this is your second carbon. So this one undergo making a bond with the carbon, but for doing so this pi bond undergo cleavage, and in that situation this oxygen become electronegatively charged, and for that reason this proton are released, so oxygen become neutral, but this hydrogen goes over the oxygen, and this way you get your structure coming out to be here. And what that structure is, just pay attention, this is something very important. So let me draw this on the left hand side first. So this is your structure. The first carbon you have is CH2OH, right? And then you have this second carbon. On the second carbon you have a OH here. Pay attention, this carbon I have placed on the left hand side, this is right here, and this O along with the H I am placing it on the right hand side. Now all other remaining carbon have nothing to do because they are, as it is. So H and similarly OH. The next one is, having OH on the right hand side and H on the left hand side. Again, this one is also having 1, 2, 3, 4, 5. This one is also having OH on the right hand side and H on the left hand side. And similarly, the last one is having a CH2OH, right? Okay, now the question is, where is the cyclic development taking place? So what I did was, I removed this hydrogen, and I made this particular development right over here. But for doing so, what we need to place the oxygen right here. So this is the cyclic structure of the fructose, where the ring is formed by the fifth carbon and also by the second carbon, right? Another very important thing is that, when you place this OH, just pay attention, when you place this CH2OH on the left hand side, this is called your alpha D, right? Alpha D, and since fructose are lever rotatory, so minus and fructose. So this is the structure of, this is the structure and the naming of this particular compound. So alpha, where the OH is on the right hand side, CH2OH on the left hand side, and D because it belongs to D series, and minus because fructose are lever rotatory and fructose its name. Now get back to the other side and see what the beta form structure is. So you see, everything is similar here, there's nothing going to change. What you need to change is that OH right here will go over the outside, and this outside CH2OH will come on the inside the ring. So that's the only thing I'm going to do. So this is your first second carbon. Now this will have a CH2OH, this will have a CH2OH, and on this way you have your OH, right? And then you have your other carbon just like them. There's nothing going to change. Just pay attention, you have to practice. But let me complete this first, then I will repeat you again. So this is OH again here, this is H here. The next one is again having a OH on the right hand side, just like the glucose also. And this last one is having CH2OH. But what I am doing here, there is no OH here because this is, involved in making the ring. So we have the O right here. So this is the structure. Now, because this OH is on the left hand side, just pay attention. This OH is on the left hand side while this OH is on the right hand side. So this is called, beta. Just pay attention. This is called your beta D, and then your lever rotatory sign, and then fructose. Then it's going to be fructose. Right? So these are the two structures of the cyclic fructose. Now we have something very important to consider, but before that I want to repeat. See, glucose and fructose has some similarity. What? Glucose is also a 6-carbon molecule, fructose is also a 6-carbon molecule, right? Glucose also undergo hemiacetal cyclic development, fructose also undergo hemiacetal cyclic development. Now go to the difference here. The cyclic development in the glucose was taking place between the first carbon and the fifth carbon, but here this development is taking place between the second carbon and the fifth carbon, right? So that's why it forms a 5-membered ring where 4 carbons and 1 oxygen is there. But in glucose, the ring was a 6-membered ring where 5 carbon was with 1 of the oxygen. So these are some of the differences, right? Another difference was that a glucose is a dextrorotatory, however, a fructose is a lever rotatory. And then there's something similar, and what that similar thing is that? Similarity between glucose and fructose is that these two beta and alpha, they are actually in equilibrium to each other. So I'm placing a reversibility sign. Just pay attention. These two are interconvertible. Just let me get some space here. I'm just taking some more space. Sorry for this. So this is your oxygen, right? And these two are again in equilibrium. So these two forms, that beta and this alpha, they are constantly interconverting, right? And this will continue unless there is an equilibrium in the system, right? So there's so many things coming up, like they will also exhibit mutide rotation, but the thing is that that's not going to be, something important here in the fructose, because fructose is a very small topic for your syllabus. So that's no need to talk about, any other extra, topic about. So this is the cyclic structure of the fructose. You know what? I think I have explained you in the finest way possibly I could do, right? So what I'm going to do now is that I'm going to, finish this right here, and I would say, thanks for watching. But, all what you need, I would, request you back here that even, there is a fraction of like you have for what I'm trying to do, for all those students who need out there, do me a favor, and that favor is you can, share with your friends. You can, like it, you can, definitely need to, put some comment, which I'm really not getting. And, of course, subscribing and increasing, the members, that will also boost me up. Anyway, thanks for watching, and do consider about the request I just made you.